Let us note down the areas and perimeters of a few regular geometric two-dimensional figures. So the first one is a circle with radius r. So the perimeter for the circle is going to be equal to 2 pi r. This is a well-known formula, and the area is going to be equal to pi r square. The second one happens to be an ellipse with the semi-major axis as A and the semi-minor axis as B. So the perimeter of the ellipse is a generalized circle. So if you equate A with B, you get a circle basically. So the perimeter of this ellipse is going to be equal to pi into A plus B. This can be proven using line integrals. So area of the ellipse is going to be equal to pi AB. It can be noted that if A is equal to B is equal to R, then the ellipse becomes a circle, and the formulae for the perimeter and the area also become the formula for the perimeter and the area of the circle. Next is a square with side A. So the length of the side is A over here. So the perimeter naturally happens to be equal to 4A, and the area of the square A happens to be equal to A square. So this is a rectangle with length L and breadth B. So the perimeter of the rectangle is equal to twice L plus B. This should be obvious. And the area of the rectangle is equal to LB. So this happens to be an equilateral triangle with side A. So since the side is A, then the area of the equilateral triangle happens to be equal to root 3 by 4 A square, and the perimeter happens to be equal to 3A. So this is an arbitrary scalene triangle with height h and base b. So there is no formula for perimeter of this triangle unless the sides are specified. So the formula for area of this triangle is half into base into height. If all the three sides are given and they are specified as A, B and C, then in that case we define the semi-perimeter S to be equal to A plus B plus C divided by 2, and we have another formula for area of this triangle, which is equal to A is equal to under root S, S minus A, S minus B and S minus C. So these are a few three-dimensional objects. So the first one is a cone. The curved surface area of the cone is equal to pi r L, where r is the radius of the base of the cone and L happens to be its slant length. The total surface area of the cone is equal to pi r L plus the area of the base. So that is equal to pi r L plus pi r square. The volume of the cone happens to be equal to 1/3 pi r square h, where h is nothing but the perpendicular distance from the vertex to the center of the base. So this happens to be the height of the cone h. For a sphere, the curved surface area happens to be equal to 4 pi r square. This can be proven using surface integrals. The total surface area is nothing but the curved surface area of a sphere. The volume happens to be equal to 4/3 pi r cube. What to do if an hemisphere is given? So if it is a hemisphere like so, then curved surface area for hemisphere is going to be equal to 2 pi r square, because it has half of the curved surface of the sphere, and total surface area for the hemisphere is going to be equal to 3 pi r square. because the area of the base circle gets added in total surface area. And volume of the hemisphere is going to be equal to half of the volume of the sphere, which is 2/3 pi r cube. For a cylinder, the curved surface area, so this is the cylinder with base radius as r. So this is drawn in perspective view, that's why the base is looking to be thinner than the upper surface. Actually both of them have the same area. So curved surface area for the cylinder is nothing but 2 pi r into h, where h is the height of the cylinder. So h is the height, 2 pi rh is the curved surface area. Total surface area for the cylinder is going to be equal to 2 pi rh plus twice into pi r square. So the upper circle's area and the lower circle's area get added over here, and volume of the cylinder is going to be equal to pi r square h. So this is a cuboid or a rectangular parallelepiped. So we can say that for this particular diagram, this is the length L, this is the breadth B, and this happens to be the height H. So basically so there is no curved surface over here, so the total surface area for the cuboid is going to be equal to, so each face has the area that is equal to product of the sides that constitute of the face. So it's LB plus BH plus LH. Okay, so these are only three faces. There are opposite faces also, so into 2. So this is the total surface area, and the volume is going to be equal to LBH. If it happens to be a cube, then things get simplified. If this thing happens to be a cube, then in that case, for a cube, L, B and H, all three of them are congruent, and you have got only one value A, which is the side of the cube. So total surface area for the cube is going to be equal to area of one side is A square. So there are total 6 sides like this, so it's going to be 6A square, and the volume of the cube is simply going to be equal to A cube. So these are few geometrical formulae for geometrical figures that we need to know.